Big line now. Guys, is it clear? Can you see the board? Is there a lag? It's not clear, no? Okay. We'll just go on with this. We'll see. Okay, if there's a problem, just let me know. We'll carry on. Okay. Right. So A is equal to C, angle in same segment. Then we need to find out B and D angles. So how can we find out B and D angles? So if you see this angle, they have given it to us over here. And this is a straight line. Therefore, we can find out this angle. We can find out that angle. How do you find that out? Angle on a straight line, this is 48. Then this angle, therefore, is going to be 180 minus 48. 180 minus 48, you're going to get 132 degrees. So this angle here is going to be 132 degrees. Okay, right? And then if you take this triangle, right? This angle is 132, this angle is 25, then we can find out D angle, angles in a segment, in a triangle, interior angles of a triangle. So we will say 132 plus 25, okay, 132 plus 25 plus D is equal to 180. And we'll find out D first. So 132 plus 25, 157 plus D is equal to 180. D therefore is 180 minus 157. D therefore is 23 degrees. So therefore we can find out D is equal to 23 degrees. Yeah, 23 degrees. Now, what did we say? B and D angles are equal. Why? Angles in the same segment. Therefore, we will say B angle is also equal to 23. So, what are the three angles? C is 48, B is 23, and D is also 23. All right. C is 48. B and D are 23 degrees each. That is your question number 8, part A. Question number 8, part A. Please take it down. If you have done it, then please check. Put a red tick mark. Okay. I hope now if I'm going fast, please tell me. Otherwise, I'll continue at this pace. Right? Hope everybody's got that. Right. Let's go on. All right. Question number B of part A. Question number 8. There is a diagram. In the diagram, AB is parallel to BC. They are given that to us. And there is a diagonal DB. There is a diagonal AC also. And this angle is X. That angle is X. They are saying prove that AXD is equal to 2DCX. So we'll do that first. So first part, prove AXD angle is equal to 2 times DCX angle. 2 times DCX angle. Right. So looking at the two diagrams, and what is the data we have? AB is parallel to DC. So AB parallel to DC, then AC becomes a transversal, DB also becomes a transversal. Okay, right. So what do we want? We want AXD angle. AXD angle, that is this angle. We want to prove that this angle is equal to 2 times of this angle. Right? I'm just marking it in red. 2 times of that angle, which is DCX. All right. So let's see how we can go about that. We know these two angles are parallel. So we can say BAX angle and DCX angle are equal. Why? BAX angle is equal to DCX angle. Why? Alternate angles. Alternate angles. So we'll give them these two a name. We'll say it is A. This is also A. All right. We'll give them A. Then BAX angle. Now look at this. Look at the carefully. Look at the diagram. This is your circle. BC is a chord. Then this angle, that is CAB angle, or BAX angle, that is this angle, and this angle, that is CDX angle, are angles on the same segment. You followed? Angles on the same segment. What is this? This angle and this angle are angles on the same segment. So since we call this A, we call this side also A. Followed? Okay. Right. So we write that down. Since AB is parallel to DC and BC is a chord, this angle, that is BAX angle, is equal to CDX angle, angles in same segment, right? Angles in same segment, right? So these are theorems that you have to know. You have to know these theorems by now. Okay. Then if you look at this triangle, in triangle DCX, this angle and this angle are equal to each other. You followed? In triangle DCX, we can say CDX angle is equal to DCX angle. Right? Therefore, CDX angle is equal to DCX angle. Right. Now, where are we coming to? We want to prove this. We want to show AXD is equal to DCX. Right. So, if you look at triangle DCX over here and CA is extended, this is an exterior angle. What is the exterior angle? AXD angle is an exterior angle of CDX triangle. Okay, so we can say AXD angle is equal to, what is the theory? Exterior angle is equal to the sum of the two interior opposite angles. So sum of two interior opposite angles are this angle and this angle. Right? So AXD is equal to CDX angle plus DCX angle. Okay. Now, therefore, we can say AXD angle is equal to A plus A, already given, A plus A. AXD is equal to 2A. Now, CDX and DCX are equal to A. You followed? CDX and DCX both are A, so we can say is equal to A. So AXD is 2 times A. What is A? DCX and CDX are both A. So instead of DCX, what we will do, we will say AXD angle is equal to 2 times A, which is DCX. This is what we want to prove. AXD is equal to 2 times of DCX. Okay. Any questions so far? Is that clear? Where do you want to? Okay, I will explain it again. Yusuf, now you need to pay more concentration, huh? Right? Pay more attention, right? So first and foremost, what you have to do is now you have to. I'm going to be a little tough. What I'm saying is, we are getting closer to the exams, right? So theorems, please study the theorems very well. Because in order to do the geometric questions, you have to know the theorems very well. Okay, study the parallelogram theorem, angles between parallel lines, areas between parallel lines, and all of that. Okay, so Yusuf, once again for you, what are they asking you? They are asking you to prove AHD angle is equal to 2 times DCX angle. Okay. What is the data we have been given? AB is parallel to DC. AB parallel to DC. So you have AC diagonal, BB diagonal. So AC diagonal and BB diagonal become the transversal between the two parallel lines. Okay, right. Then our main purpose is to bring the DCX into the calculation, right? So if you look at this, BAX angle and DCX angle are angles which are alternate to each other, alternate angles. So alternate angles are equal to each other. So we are saying this is A, this is also A. So we're going to call them equal to each other, alternate angles, right? That is the first thing. Then we also, when you look at this, right, you can see BC is a chord and BAX angle and CDX angle are angles in the same segment. Angles in the same segment, again, according to theorem, are equal. So since we gave this A, we'll give this angle also A and say both of them are equal. So that's what we did here. BAX angle equal to CDX angle, angles in same segment. Right? So therefore we are saying CBX is equal to DCX is equal to A. Right? Now we have to bring the AHD into the picture. Now AHD angle, if you look at it, it is this angle. Right? AHD therefore is your exterior angle of CDX angle. Exterior angle of CDX angle. So according to the law, exterior angle is equal to the sum of the two interior opposite angles. So what are the two interior opposite angles? CDX and DCX. We name them as A. So A plus A is equal to 2A. Now going back to the question, we need to prove DCX is 2 times AXD. DCX is A. So we are saying 2A. Instead of A, we are bringing DCX into the picture to prove this. Okay? Yusuf, okay? Clear? All right, good. That is question number B. Any questions? I sent you that correction last week. You didn't see that. I told you to put it into a circle. I sent you a cute paper 6 correction. Okay, all right. Right. All right. Let's go on. Question number 9. Another geometry question. They're saying ABCD is a rectangle. AB side is greater than BC side. So that means AB is the length of your rectangle, BC is going to be the breadth of your rectangle. Okay, so you need to make that, be very clear with that. Right? A, B, C, and D. Okay. Then they are saying X is a any point on DC. So X, we'll name it over here. So X is this. X is any point on DC. AX is produced to meet at Z. So AX is produced to meet at Z at the straight line drawn through C parallel to BD. So first we'll draw BD. So BD is this. Then they are saying a line drawn through C parallel to BD, right? And this AH line is produced so that it meets the line parallel to C at Z. Follow? At Z. Is the board blurry, guys? Abdullah, can you follow the recording? I'll say the recording is there. Okay. Right. Question number. This slide, because we are a little short of time, Abdullah. I'll come back to you once we are done. Okay. Right. So question number, the X is on DC. Line parallel to DB is this. Okay. And they are saying when AX is produced, it is meeting at Z. That's your diagram. Okay. All right. Now, they are saying draw a diagram and mark the above data on it. So we have done that. Draw the diagram. AB is greater than BC. X is a point on DC. AX is produced and it is meeting the line drawn through C, which is parallel to BD. Okay. So we just put and show that these two are parallel to each other. All right. Now, they are saying in question number 2, prove that the area of triangle ADX, right? Where is ADX? ADX, that is this triangle, right? Plus triangle BCX. So BCX, let's join this. BCX, right? So I'll just put it in a different color. So these two, these, when you add these two, they are saying it is equal to half the area of the rectangle ABCD. So it is half the area of this rectangle ABCD. Okay, right. Let's go on and see what we need to do. Fine. Okay. So in this triangle, sorry, in this rectangle ABCD and triangle ADX, you can see are lying on the same base AB, right? So we'll say triangle ABX and rectangle ABCD, okay, triangle ABX and rectangle ABCD lie on the same base. Same base. What is the same base? AB. This triangle and this rectangle both are on the same base AB. Right? Lie on the same base AB between same pair of parallel lines. Same pair of parallel lines. What are the parallel lines? In a rectangle, we know opposite sides are parallel to each other. So AB is parallel to CD. Okay. So ABX triangle and triangle ABCD, rectangle ABCD lie on the same base AB between same pair of parallel lines ABCD. Okay. So in that case, we know that area of triangle ABX is equal to, right, triangle of ABX is equal to half the area of rectangle ABCD according to the theorem. According to the theorem, area of triangle ABX is half the area of a rectangle ABCD according to the theorem. Why? Because they are lying on the same base between same pair of parallel lines. Right? Okay. Right. So then area of triangle ABX is this, is equal to half the area of triangle ABCD, which is according to theorem. Right. Now we know area of your rectangle. Area of rectangle ABCD is equal to area of triangle ABX plus area of triangle ABX plus area of triangle BCX. Okay, area of triangle BCX. What are we to prove? That the area of the two triangles, these two, is equal to half the area of ABCD. Okay, so we know area of triangle ABX is half of area triangle of ABCD. Okay, so what we'll do is we'll take the area of triangle ABX onto this side. So we are going to remove it from the area of the triangle ABCD. So area of triangle ABCD minus area of triangle ABX is going to be equal to, so we are taking the ABX out from here and taking it out here also. So you are left with area of triangle ABX plus area of triangle BCX. Okay, triangle BCX. So when you take the area of your triangle ABX from the area of your triangle ABCD, you are left with what? Half area of rectangle ABCD, which is equal to the area of triangle ADX plus area of triangle BCX. That is what they want you to prove. Now, according to the question, what they say? Prove that the area of triangle ADX plus the area of triangle BCX is equal to half the area of rectangle ABCD. Okay, so that is what you need to prove over here. Is that clear? All right. So you need to know your theorem. Without theorem, how are you going to prove? How are you going to say, according to the theorem, only we can say that the triangle ABX is half the area of your triangle of your rectangle when they lie in between same pair of parallel lines and on the same base. So that theorem, if you don't know that theorem, you can't prove that. Okay. Got it? All right. So just to go through this in basic again, you have a triangle, you have a rectangular figure. The triangle is inside. So they are saying you need to prove that the area of the two triangles, that is ADX and BCX, when you add it together, is going to be equal to half the area of your rectangle. Okay. So first what we need to do, we'll take ABX triangle, right, and see whether that is equal to half the area of your rectangle. So we know that through the theorem, triangle ABX and triangle ABCD lie on the same base AB between same pair of parallel lines AB and CD. They both lie on the same pair of parallel lines AB and CD. Therefore, we can say area of your triangle ABX is equal to half the area of your rectangle ABCD according to theorem. Okay. Then this rectangle has got three parts. What are the three parts? Area of ADX triangle, area of ABX triangle, and area of BCX triangle. So when you add these three triangles together, it gives you the whole area of your rectangle. Now, our main purpose is to prove that these two sides, these two triangles, when you add it together, is going to be equal to half of your rectangle. Okay. So how do you do that? We know if you take the area of your triangle ABX, that is this, and it is only half of your area of your rectangle. So if you remove that from the area of your rectangle, you are getting only half the area of your rectangle left over. If you remove this triangle from the rectangle, you are only left with half the area of your rectangle, and that is equal to what is left over? The addition of your two other triangles, which is ADX and BCX. Okay, right? So that is question number 9. Please take it down. All right, let's go on to question number. Sorry, we have one more part in there. Part C. So part C says, prove that the area of ABD triangle is equal to the area of triangle BDZ. Now that BDZ also I sent you a corrected tute last week. Right, BDZ. So I'm going to take this out. I want to take this out, guys. Right. They're saying prove that the area of triangle ABD. So where is ABD? ABD. That is this. Right? ABD. Right? I'm going to erase all of this. ABD. Just give me a minute. Is equal to the area of BDZ. Now, where is BDZ? You have BD, you have Z here. So then, like this. Okay. So, what is BDZ? This area. Okay. BDZ. So, how are you going to prove this? How are we going to prove that this is equal to this? Okay. Again, theorem. You have to know the theorem. Now look at this. We know they are saying this line and this line, that is the diagonal, are parallel to each other, which is given in the diagram. In the question, they are saying, no, they are saying the line through C is parallel to BD. So, data we have is BD is parallel to, let's say, CZ. Parallel to CZ. Now, if you look at this carefully, if you see BD is your base, you have one triangle, that is BDZ here. BDZ, and triangle BDC are both lying on the same base between same pair of parallel lines. Got it? So let's write that down. So we say triangle BDZ and triangle BDC both of them lie on the same base BD between same pair of parallel lines, BD CZ. Okay, BD CZ. All right. So if they lie on the same base between same pair of parallel lines, then we know area of triangle BDZ is equal to area of triangle BDC. Yeah, area of triangle BDC according to the theorem. Okay, so that means this triangle and this triangle are equal in area because they lie on the same base between same pair of parallel lines. Okay, now what are we trying to prove? We need to prove triangle ABD is equal to area of triangle BDZ. Okay, so we write that down. Prove area of triangle BD ABD, no? A triangle ABD is equal to area of triangle BDZ. Okay. Right. So we know area of triangle BDZ is equal to area of triangle BDC. BDZ is equal to this. Now, if you see BDC triangle and ABD triangles are two triangles that make up the area of your rectangle. Right? So it has got divided by the diagonal BD. This triangle and this triangle are two triangles inside the rectangle that make up the rectangle. So a diagonal in a rectangle bisects the area of that rectangle. Right? So therefore we can say BDC triangle is equal to the triangle of ABD triangle. Okay. Right? So we write that down. Area of triangle ABD is equal to area of triangle BDC. Why? Diagonal BD bisects the area of rectangle ABCD. Followed? Right? This BD rectangle diagonal is bisecting the area of your rectangle. So you have ABD angle, a triangle is equal to BDC triangle. Okay. So now what are we trying to prove? Area of ABD is equal to area of BDZ. Now area of BDC is equal to area of BDZ. Therefore, we can say area of ABD is equal to area of BDZ, which we need to prove. So therefore, we can say area of triangle ABD is equal to, now these two are equal, BDC equal to ABD, BDC is equal to BDZ. Therefore, these two become equal to each other. Area of triangle BDZ, axioms. Remember axioms in grade 9? So since ABD is equal to BDC and BDC is equal to BDZ, then these two become equal to each other. Okay, that's what we needed to prove over there. Please take it down. Please take that down. I'll give you another 10 seconds. Okay, let's go on. Right, let's go on. Question number 10. All right. Let's go on to question number 10. Right? They are saying Venn diagram. Huh? In a sports club of 50 members, 21 members were girls. Okay? And 10 of them were aged below 15 years. Now, this 10 that they are saying is related to the number of girls. Huh? Right? You need to be careful. They are saying because it's just coming right after that. In a sports club, there are 50 members. Out of that, 21 are girls. And out of the 21, 10 are 15 years and below, aged below 15. And 11 boys are above 15. Okay. Represent the given information in the above Venn diagram. Okay, so let's start. Okay. They're giving you two circles, two sets. Below 50. Okay. Girls and below 50. Right. Let's start from the beginning. In a sports club, there are 50 members. So totally, the universal set is 50. And then they are saying there are 21 girls. So what is a set representing girls? This set. This set is representing girls. So we'll put 21 there. Right? Then we come out of the question and then we'll answer a few to make some things clear. So if there are 21 girls, then how many boys are there? Boys are 50 minus 21, which is 29. Just to make a note, just keep that there. Then they are saying, out of the 21 members who are girls, 10 members are aged below 15. Right. So if you look at the diagram, you have girls here. You have children below 15 here. They are saying 10 of the 21 girls are below 15. So that means this region means the number of girls who are below 15. Okay. Right? Number of girls who are below 15 is 10. All right. Then 11 boys were above 15. So 11 boys are above 15 means what? Boys below 15. We'll write that down. Boys below 15 therefore will be out of the 29. We know 11 are above 15. So then you subtract 11 from here, you will get 18 here. So that means how many boys are below 15? 18 of them are below 15. So look at the graph here, set here. We know this is the number of children below 15. Out of that, this region is the number of people who are girls who are below 15. So we got that. That is 10. So number of boys below 15 becomes what? This region. Boys below 15 will be over here. Okay. Boys below 15 comes here. Then the number of girls who are 21, 15 are number of girls are 21, out of them 10 are below 15. So then this region will be the number of girls who are above 15. So 21 minus 10 is 11 are above 15. Are you following? We need to put the pieces together. Right. And one more thing we need to put. We know boys, there are 21 of them. Out of that, 18 are below 15. Then the balance number is how many? This 11 are the number of boys above 15. That will be the region outside this. And that is over here. You follow? Okay. So let's just put this in, let's just mark the areas. Boys above 15. Boys above 15. This is girls above 15. Then this girls below 15. Right? Then this is boys below 15. Understood? Right? These are the different regions. Girls above 15, boys above 15, girls below 15, and boys below 15. Okay. Right. Now let's just quickly answer the questions. Represent the above information in the above Venn diagram. We have done that. Then they are saying how many boys were less than 15? How many boys less than 15? 18 that we have done. Already calculated. That is question number 2. Then find the probability of the sports club members who were above 15 years old. So third question, probability of members above 15. So we know total number of members, there are 50. How many girls are above 50? 11. How many boys are above 50? 11. So 22 over 50 is your answer. Okay, that is your question number 10. First 2, 3 questions. This first, second, and third question. Okay. $22 over 50, you can simplify if you want. How much is that? Divide by 2, you get 11 over 25. That is also fine. No problem. Okay. Right. Then the second part of that, sorry, fourth question, it says, in the given tree diagram, find the probability of P, Q, R, S, T, and U. So let's draw the diagram first. Boys, girls, right? Then this is gender. Then you have the age. Right? Above 15, below 15, girls also same. above 15 and below 15. Okay. Then let's try to fill in the blanks. Boys, what is the probability that you are picking a boy? Is 29 out of 50. Picking a girl, 21 out of 50. Okay. Then they are asking, so we know the number of boys who are above 15 is how many? Boys above 15 is 11 out of 50. Yeah, boys above 15 is 11 out of 50, and below 15, boys below 15 is 18 over 50, and probability of a girl being above 15 is how much? 11 out of 50, and girl being below 15 is 10 out of. So those are your probabilities for question number 4. Okay. I'm sorry about the board. It's still not clear. I have something wrong with the camera. I don't know today. There is no theory for a tree diagram, Yusuf. Just probabilities. What is the chance of something happening? Probabilities. What is the chance of a certain event happening? Right. So here, what is the probability of a boy being chosen? So out of the 50 members, 29 members are boys, 21 are girls. Okay. Then they are looking at the age. So if you pick a child out of that who is a boy above 15, what is the probability? Probability you're going to get a child is 11 out of 50. Who is a boy above 15? Probability of boy below 15, you picking one is 18 out of 50, because 18 children, boys, are below 15. Likewise, in girls, what is the chance of you taking a girl who is above 50? 11 out of 50. Why? Because a girl above 15 is 11 out of 50. So what is the probability of you taking a child, or sorry, a girl who is below 15? 10 out of 50. Okay. That is question number 10. All right. So paper 6 done. Paper 6 done. Let's go on and continue with the balance. So paper 7, people, please take paper 7 out. Paper 7 out, please. Right, let's go on. Paper 7. First question. Mr. Pereira invested 50,000 and bought shares in a company at the market price of 50 per share. The company pays annual dividends of 6 per share. At the end of the year, after receiving dividends income, he sold all his shares at 70 rupees per share. Find the number of shares Mr. Pereira bought. So question number 1, part 1. Number of shares is equal to, he spent 50,000 divided that by the market price. That's the price he paid for each share. So 50,000 divided by 50. This and this will cancel. 5,000 divided by 5. You will get 1,000 shares. That's your first question. Okay. Question number 2. Find the annual dividends income Mr. Pereira received from this investment. So every share that you hold, you can get 6 rupees as an income. So what is the dividends income? He is holding 1,000 shares. Each share is 6 rupees. So 1,000 into 6, his dividend income is 6,000 rupees. Okay. Find the amount he receives by selling his shares. That is third. Right. Third one, we'll say share sale income. Shall we say that? Share sale income. Because he's selling those shares. How many shares is he selling? He's selling 1,000 shares. At how much? He sold all his shares at rupees 70. So 1,000 into 70, he got 70,000 rupees. Okay, is that clear? Find his capital gain. Find his capital gain. So what do we mean by capital gain is the profit that he makes from buying the share to selling. So only the capital amount, not dividends and all don't come into that. Capital gains is he bought it at 50 rupees, sold it at 70 rupees. So what is that capital profit that he is making? Right? So capital gain is both capital gain. He's selling it at 70. So 70,000 minus he bought it at 50,000. So he's making a profit of capital gain of 20,000 rupees. Okay. That is fourth question. Express the capital gain as a percentage of the amount invested. Yeah. Express the capital gain amount as the amount as a percentage of the amount invested. So what is the capital gain percentage? That is 20,000 over 50,000 into 100. Yeah. So 4 zeros cancels. 200 divided by 5, you get 40% is your capital gain percentage. Okay. That is question number 1. Take a few minutes, take it down. All right. Can we go on? Okay. Question number 2. An incomplete table of values to draw the graph of the function y equals x squared minus 2x minus 2 is given. First, find the value of y when x is equal to 0. So let's do that quickly. When x is equal to 1, y equals 1 squared minus 2 into 1 minus 2. So 1 squared is 1. 1 minus 2 is minus 1. Minus 1 minus 2 is minus 3. Okay. That is your x. So they are saying by taking the values 10 small divisions, find the value of that. Okay. So let's go into that. Let's draw a graph. So in your graph, x is equal to, you see from minus 2 to plus 4. That is on the x-axis. And on your y-axis from plus 6, you're coming down to minus 3. So you have to draw your graph in such a way that you have all of that covered. Okay, so before you start drawing the graph, just look at what is the amount of space you need. Don't go and draw the graph to one side. Then after you doing a couple of minutes, you see that you don't have enough space. So you have to plan yourself out before you start drawing the graph. Look at the x-axis. From where to where you need to draw. So do you need to take the graph into the middle of the graph paper? And then you need to see your y-axis from positive to negative. That also you need to see whether you're going to need more space on the top or you need more space at the bottom in the negatives. So you need to plan all of that before you start drawing. Otherwise, after you draw and you get stuck, that means you're going to waste a lot of time and then again you're going to redo it. And that, unnecessary pressure, you're tense because you're in an exam, and then it can really go wrong. Okay, so plan yourself out. Before you start a question, read the question and see whether you can do the question. Because each of us have strengths. I am good at geometry. Some people might be good at the algebraic questions. Some people are good at the graph questions. So though everybody has a strength. So before you do the paper, they give you 10 minutes to read the questions. Right? So just have a glance through the 10 minutes and see what are the questions that you are going to attempt. Okay. Right? So please, as I'm telling you right now, plan yourself out. Don't start a question halfway, you spend 10 minutes and then decide, oh my God, I can't do this question. Right? So those things you need to be very careful. Right. So your graph from your y-axis to your x-axis. So x-axis, we'll draw the y-axis first. That's easy. Okay. So -2 plus 6. So -2 plus 6, let's go that. -2 plus 6. Then -1 plus 1. -1 plus 1. 0 minus 2. Then 1 minus 3. 1 minus 3. And 2 minus 2. 2 minus 2. 3 plus 1. 3 plus 1. And 4 plus 6. Okay. Right. So let's plot the graph. Okay. So try to draw a smooth curve, guys. Right. As much as possible, draw a smooth curve. Right. So graph over here to take a smooth curve like this. All right. Okay. So what is the name of your graph? Y equals x squared minus 2x minus 2. Okay. That's your graph. Okay. Right. Then very carefully look at the question. It says by taking 10 small divisions of the graph paper to represent 1 unit. So 10 small divisions is equal to 1 unit. Very clearly they're telling you how the graph should be drawn. Don't do it according to what you want. Okay, so every unit has to be equal to 10 of those small divisions along the x and the y axis and draw the graph of the above function. So please be careful in how you do that. Okay, using the graph, find the coordinate of the turning point. So what is the turning point? This point. What is the turning coordinate? +1 minus 3. So +1 minus 3 is the turning point or the coordinate. So need to write that down. 1 minus 3. Okay. Then write down the equation of the axis of symmetry. So what is the axis of symmetry? Where the graph is dividing into two equal parts, more or less where it's the turning point. Okay, so your turning point is over here. So you need to draw the axis of symmetry. And your axis of symmetry, what is the name of your axis of symmetry? X is equal to, it is going through the +1, so x is equal to 1. Okay. Next, find the range. Find the range of value of x for which the function is increasing positively. Increasing positively. Again, we did this last week. I'll do it again. This is your x-axis. Values above your x-axis are positive. Values below the x-axis are negative. So your function is taking a minimum curve. Function is taking a minimum curve Therefore, from here to here, the graph is reducing positively. Then from this point, it is reducing negatively to the point of the turning point. Then from here, it is increasing positively up to this point at the x-axis. And then from the x-axis, it is increasing positively upwards. The question they're asking is, find the range of values of x for which the function is increasing positively. So where is the function increasing positively? Function is increasing positively over here. And from this point, where the function cuts the x-axis upwards, we say when this is x is equal to 2 point, let's say 2.7, I don't know. You will know better when you have your graph paper, but I think something like 2.7. Anybody got a different figure? 2.7 or 2.8? What is that? 2.8. Okay, 2.8. So here upwards increasing positively. So x is going to be greater than 2.8. That's your region where the function is increasing positively. Okay. Right. Next. Then they're saying find the range of values of x for which y is less than or equal to 1. So first what you need to do here, children, is you need to draw the y is equal to 1 line first. So what is the y is equal to 1 line? Y is equal to 1 line is a line going through y. That is this. Y is equal to 1 line. Okay. Now they are asking you find the range of values of x for which y is less than or equal to 1. So here any point on this is equal to 1. Above this is going to be greater than 1. So here what they are asking is what is the value of x which is going to be when y is going to be less than or equal to 1. So your graph, when it takes a point from here like this all the way up to here. Okay, that's your x value. Why? If you take a value here, x is going to be minus 0.8 and y is going to be 0. If you take a point here, x is going to be 0, y is going to be minus 2. Take here, x is going to be 2, y is going to be minus 3. And up to here, the y value is going to be below the 1 value. So they want you to know what is that range. So your range therefore is x is greater than or equal to minus 1. Okay. And greater than or equal to, sorry, less than or equal to plus 3. From here to this point, if you see, if you draw a perpendicular like this, you will see that figures. Okay. So x is going to take when x will be greater than or equal to minus 1. And it goes all the way up to here and up to here, less than or equal to plus 3 should be your answer. Okay. So that is question number 2. Small divisions. Small divisions is in your graph paper. If you see your graph paper, I don't have a graph. Wait 1 minute. So in your graph paper, you see your graph has been divided. Every box there are small divisions. Yeah, small divisions over here. So they want you to take 10 divisions as 1 unit. Okay, 10 divisions as 1 unit. Is that clear? Any questions? In the second question, what do they mean by three nodes? All right. Ahmed, doesn't it increase until 4? No, it doesn't increase until 4. It only increases up to this point. Increases up to 4, fine. But they are saying less than the 1. Y is equal to 1. So up to this point. Right? The function goes up to 1, but that's fine. But they want to know only the range where y is going to be less than 1. So y is equal to 1 region is up to here only. Okay. Because if you take a point here, right? So if you draw this, draw a perpendicular, and here you will see 3.5 and y is going to be 3. So you can't have y greater than 1. So they are saying they want y less than or equal to 1. Amen. Increasing positively, yeah. Fifth question, is it? Yeah, so fifth question we are saying greater than 2.8. Increasing positively means greater than 2.8. From here it's increasing positively and going. Okay. So you want to, they're not asking the range, or they say range. Find the range of value of x for which the function is increasing positively. Okay. X is greater than 2.8. Okay. So yeah, you're right. So we can rewrite that when x is greater than 2.8, increasing positively, uh, less than 4. Okay, fine. All right. That also there's a clarification. Yeah, you can do that. X is greater than 2.8 and less than 4. Fine. Good. Well done. Yeah, you can write that. Any questions? Right. We'll go on to the third question. All right. Third question. Information on the runs scored by a cricket team in the 40 matches they played during the last year is given in the following frequency distribution. So interval of runs 131 to 141. They scored so many runs in 2 matches. Then 142 to 152, they scored that in 4 matches, and so on. Taking the mid value of the interval 175 to 185 as the assumed mean. Okay. Find the mean number of runs this team scored in a match to the nearest whole number, and thereby find the total number of runs that this team can be expected to score in the 60 matches that will be held this year. So let's do that and find the mean average first. Okay. So class intervals, question number 3. Interval of runs and then matches. Number of matches. Okay, right. Taking the mid value of the interval as the assumed mean. Okay, mid value of the, so we need to find the mid value first. You have 131 to 141, 142 to 152, 153 to 163, 164 to 174, 175 to 185, 186 to 196, 197 to 207, 208 to 218, 228 to 238. Sorry, 219. Okay. Then 2, 4, 5, 6, 8, 5, 4, 3, 6. So what is the mid value? 131 plus 141 divided by 2. Yeah. So what is the mid value, guys? Can you tell me? 131 plus 141 divided by 2. You will get 146. 136. No? 142 plus 152 divided by 2. You will get 147. I'll just do one and just show you, and then you can do the calculation. Huh? So 131 plus 141, 7 2, 272 divided by 2 is 1, 7 divided by 2 is 3, 12 divided by 2 is 6. So 136. 153, 163, add it and divide by 2, you will get 158, 164. Guys, one more thing. When you do calculations like this, these are very simple calculations. Please don't make a mistake, because the whole, you make one mistake, the whole thing will go wrong. Okay, so please be very careful. These are simple additions and then a division. So please pay a lot of attention, because here only we tend to make mistakes. Because we know it, we do it in a hurry, and then we do a silly mistake, and that whole question will go wrong. Okay, so please be very careful and pay attention. So 174 plus 174 divided by 2, you get 169. Then 175 plus 185 divided by 2, you get 180. 186 plus 196 divided by 2, you get 191. 202, then 213, and 220. So those are your mean values. Okay. Then they are saying, taking the assumed mean of being the mid value of 175 to 185. So 175 to 185, the mid value is 180. Okay. Mid value is 180, right? So let's find the deviation now. So deviation, okay, deviation, right? And then we'll need one more column, no? FD, sum of FD. Right. So let's take the deviation. 136 minus 180, you get minus 44. 147 minus 180. You know how to calculate deviation, no? To take this value and subtract the assumed mean. Okay. So 136 minus 180, 44 minus 147 minus 180 minus 33, 158 minus 180, you get 22 minus 22, 169 divided by 180 minus 11, 0 plus 11, 22, 33 and 44. Okay, and 44. Right. Now sum of FD means 2 into 44 minus 88, 4 into minus 33, 4 into minus 33, how much are you getting? Minus 132. 5 into minus 10, minus 110. 6 into minus 11, minus 66. 8 into 0, 0. 5 into 11, 55. 4 into 22, plus 88. 3 into 33, 99. 3 into 44, 132. Okay, just double check your answers. Huh? 88, 132, 110, 66, 0, 55, 88, 99, and 132. Okay. Add these two, it's easier to do. So 188 plus 132. So we'll add 8 plus 2, 10, plus 6, 16. 1 plus 8, 9, plus 3, 12, plus 1, 13, plus 6, 19. 1 plus 1, 2, plus 3. 396 minus, right? Minus 396. 5 plus 8, 13, plus 2, 15, plus 9, 24. 2 plus 5, 7, plus 8, 15, plus 9, 24, plus 3, 27, 374 plus. Okay. So sum of FD will be how much? 396 plus minus 396 plus 374, subtract 9, 6 minus 2 is 6 minus 4 is 2, minus 22. Okay, minus 22. Then you also have to find the number of matches, sum of F. 2 plus 4, 6, plus 5, 11, plus 6, 17, 17 plus 8, 25, 25 plus 5, 13, 34 plus 4, 34 plus 3, 37 plus 3, 40. Okay, right. Now they are asking, find the mean number of runs this team scored in a match to the nearest whole number. So how do you calculate mean? Mean is assume mean plus mean deviation. So assume mean is 180 plus mean deviation is sum of FD over sum of F. So sum of FD over sum of F, how much is that? 180 plus minus 22 divided by 40. Right? Minus 22 divided by 40. How much you're getting? How much are you getting? Can somebody quickly do a calculation? Minus 22 divided by 40. Yusuf, in the question, very clearly asked, find the mean number of runs this team scored in a match to the nearest whole number. In question number 1. Come on. Concentrate. Minus 22 over 40 divide. You're going to get minus 0.55. So 180 minus 0.55. You'll get how much? 179.45. So they are asking you to round it off to the nearest whole number. So 179 runs will be your answer. Okay, that's your first part. So then if they're asking you what will be the total number of runs in the 60 matches that they score, that's what they're saying. Thereby find the total number of runs that this team can be expected to score in the 60 matches that will be held this year. Already 40 matches done. So total number of runs in the 60 matches will be second part of the question. Therefore, 179 multiplied by 60. Can somebody quickly tell me how much that is? Why are you worried about continuing data and all of that, Ahmed? There's nothing to do with that, no? Everything has been given to you. You don't need to do that. Don't confuse yourself too much. Okay. 10,740. Good. 10,740 runs. All right. Then third part of the question. Or is it third or second? I don't know. Let's do that second, no? So this is your first part. This is your second part. Good. All right. They're saying, show that the maximum number of runs this team may have scored in total in the 10 matches which they scored the most number of runs. So the most number of runs they scored in this. This is the most number of runs. That is over here. Okay. The most number of runs is from 197 to 207, 208 to 218, 219 to 229. So they are saying, show that the maximum number of runs this team may have scored in total in the 10 matches which they scored the most number of runs. The 10 matches is 4 plus 3 is 7, plus 3 is 10. During the last year is less than 2,170. So how do you show that? They are saying the maximum number of runs. So you take the top figure out of this. From 197 to 209, 207 runs they could have scored. But they are saying, so we'll take it as 207 is the maximum. So 207 into 4 plus 218 into 3 plus 229 into 3. Okay. So if you take those figures, 207 multiplied by 4 and 218 multiplied by 3, 229 multiplied by 3, your total runs you're going to get is 2169. Okay, do that calculation and see. Why can't we take 196 for what? For what usage? 10 matches, maximum 10 matches is 4 plus 3 is 7, plus 3 is 10. So the 10 most runs matches, if they score the highest runs in each match, maximum runs. Yeah, so maximum runs is 207 for this, 218 for this, and 229 for this. Okay. So 207 into 4, 218 into 3, 229 into 3, you're getting 2169, and they are saying that is going to be less than 2170. So you need to say, therefore, 2169 is less than 2170. You show it like that. Okay. All right. So third question done. So we come back to do the fourth question, right? Next week. So fourth question, fifth, sixth, and then we go on to paper 8 accordingly. Okay. All right. So thank you. Take care. God bless. And good night, guys. Okay. Bye bye. Good night. Bye, guys. Please practice. Good night. Good night. Take care. Bye bye. You have a good weekend, Yusuf. Take care. Bye bye. God bless. Bye, Sayush. Take care. Bye, Charlene. Bye, Shaheen. Sorry. Bye, Shaheen. Take care.